Hello students, how are you? I hope you are doing well. I came with four questions based on modern physics. These questions were asked in the second shift or the afternoon shift of 24th January 2023 JE mains. So let us discuss them one by one. Coming to the first question, an alpha particle, a proton and an electron have the same kinetic energy. Which one of the following is correct in case of their de Broglie wavelength? So here de Broglie wavelength is lambda, and the subscripts they are clearly given for alpha particle, proton, and electron. We have to arrange them in ascending or descending order. Now you see de Broglie wavelength, de Broglie wavelength, okay, is simply given by h, that is Planck's constant upon linear momentum. Now since we have been informed that they travel with the same kinetic energy, so let us replace momentum in terms of kinetic energy. So momentum in terms of kinetic energy will be what? Under root 2 mk, where m is the mass, k is the kinetic energy. Now h is constant, k is constant, 2 is constant. So therefore we can write that the de Broglie wavelength varies inversely as the square root of their mass, respective masses. Now you know alpha particle is a helium nucleus. It has highest mass and its mass is 4 mu. Proton has a mass 1 mu, whereas electron has a mass of around 1 upon 1837 times of AMU. 1 upon 1837 times of AMU. So this is what you have. So since lambda varies inversely as root m, I can write lambda A less than lambda P is in turn less than lambda E. So correct option is second option. Clear? Let us move to the next question. This is a matching type question. Match list 1 with list 2. As you can see in list 1, there are 4 different kinds of waves. Okay. These are all electromagnetic waves which are used for communication purpose. They are principally employed for communication purpose, and the list 2 provides the range of frequency. So we have to match them. Now as you can see here that amplitude modulated wave has the lowest frequency. Frequency modulated wave has more frequency. Television has still more frequency, and satellite communication has still more frequency. In fact, as you go from towards the bottom, from top to bottom, the frequency range keeps on increasing. Frequency range keeps on increasing. So if you can arrange them, you get the answer simply. Now you see, basically, more the frequency, okay, more will be the information carrying capacity. Higher the frequency range, more will be the information carrying capacity as a rule. So amplitude modulated waves, basically they are employed in radio service, radio, and that too when we were young, like maybe around 30 years back, 1980s and 1990s. Okay, mostly there were not even 90s, during 70s and 80s, I should say. Radios used to employ amplitude modulated wave. The sound quality was very, very inferior kind of a thing. Okay, so somehow we could manage. So this will be A, this can be mapped to A. Then, frequency modulated wave is slightly better. Okay, its frequency range will be more and the sound quality is slightly good. I think you all are aware of this FM radio. So nowadays FM radio is also popular. So slightly more than that, this should be mapped to 1 FM. Then comes television. Television is this, and satellite communication has the highest frequency. Now, just a small piece of information, students. AM and FM, till FM broadcast waves, the electromagnetic waves get reflected at the ionosphere. Ionosphere is the topmost layer of atmosphere. Okay, so there it gets reflected. So the waves travel along the Earth's surface by undergoing reflection at the ionosphere. Whereas these television signals and satellite communication signals, their frequency is much high and they don't get reflected, rather they get refracted through the ionosphere. For electromagnetic waves to get reflected, there is a minimum frequency that is known as critical frequency. Okay, so A is 2, B is 1. So this should be the correct answer. First option should be the correct answer. Okay. In case if you have television, you can just check the frequency of corresponding to different what you call channels. Okay. Nowadays digitally they display. The television will display digitally all the frequency range in which each channel is operating. So mostly you will find that they range in this. The frequency will always range in this. Okay. Right. Let us move to the next question. Then the third question. This is third question. The logic gate equivalent to the given circuit diagram. So the best way to solve this is by drawing a what truth table. So let us form the truth table. Then we can immediately check what is happening there. So 0 0 0 1 1 0 1. Now you see 0 0 means it is removed and A1 is removed and B1 is also removed. So what happens basically, current will flow through this. As current flows through this bulb, it will glow. So the output is 1. Now either A1 or B1 is removed. So there is no question of current going through this. So current has to flow through this. The entire current will flow through this because this is after all 0 volt. So here it will be 1. But just imagine what will happen if both are closed, A1 and B1 are closed. And this portion being short circuited, the entire current will flow through this way. Because here the bulb will have certain resistance. So if there is an option available for the current to choose a resistanceless path, the entire current will flow through the resistanceless path. I am talking of this port. In that case, the bulb will not glow. So as you can see that this truth table corresponds to that of a NAND gate. NAND gate. You can check very easily. And negated. NAND is nothing but and negated. Write down the truth table of and just negate it. Just reverse it. You get it. So the correct option is second option. Then coming to the fourth one. A photon is emitted in transition from n equal to 4 to n equal to 1 level in hydrogen atom. The corresponding wavelength for this transition is. You have to obtain the wavelength. It's very simple. Now, as you know, when a when an electron jumps from higher orbit to lower orbit, the difference in energy will be emitted in the form of a photon. Is it? This will be emitted in the form of photon, and that is given by 1 by, suppose this is n1 and this is n2. So 1 by n1 square. So 1 by n2 square and it's 1 by n1 square. Okay. Remember n1 is greater than n2 square into 13.6 electron volt. This formula you are aware of this. And this energy we can write it as hc by lambda. If lambda is the wavelength, then the corresponding energy is hc by lambda. So this I can write. So here the transition is from where to where? N equal to 1 to n equal to 4 into 13.6 electron volt. Now H is given as 4 into 10 to the power minus 15 electron volt. C is 3 into 10 power 8 meters per second. Okay, lambda we have to calculate. This will be 15 by 16 into 13.6 electron volt. So 3 5s are 15. That is the only cancellation possible, it seems. So lambda goes up. Here you are left with 4 into 10 power minus 7 into 16, of course, upon 13.6. Okay, so this is second also. This much second. So second gets cancelled here. Okay, so since we have to calculate in nanometer, okay, so let us multiply and divide by 100. So when you divide by 100, 10 power minus 7 and divide by 100 is 10 power minus 9. So this will be 400 into 16 upon 13.6 meter. Okay, this 5 is also there. So when you calculate this part, you'll approximately get around 94.1 nanometer. So this is the first option. Now students, a small piece of advice. You see, all the three options are quite close to each other. Quite close to each other. So if your calculation is fast and perfect, only then you solve these kind of questions. Otherwise, unnecessarily you will be losing lot of time here in calculating this. So make sure that while attempting these kind of questions, you should be confident enough with your speed and accuracy calculation. Simple calculation, of course, multiplication, division, and all. Otherwise, my sincere advice will be to just omit or leave these kind of questions so that at least you don't waste time unnecessarily. Okay, let us move to the next question. That is the fifth one. The energy released per fission of a nucleus X is to 200 million electron volt. So the energy released if all the atoms in 120 gram of pure this undergoes a fission. Here you see students, the powers of 10 have been expressed in red color. Okay, because of some technical problem, I'm not able to take it as a power. I'm not able to express it as a power. So basically, the subscript kind of a thing in red is actually power of 10. Okay, so this is very simple. You see here, the energy released per fission is this much. So we have to calculate energy released if all the atoms containing 120 gram of this undergo fission. Simple. So energy released per fission multiplied by the number of fissions. So the required energy will be energy per fission. Energy corresponding to each fission then multiplied by total number of fissions taking place. Is it? So energy per fission is how much? 200 million electron volt. So 200 million electron volt. Now number of fissions means number of atoms. So you see the mass number, which can also be taken as the atomic number, is 240 grams. And the mass is this. So I can write number of fissions is equal to number of atoms. And number of atoms is nothing but number of moles multiplied by Avogadro number. So number of moles is this multiplied by Avogadro's number. So this is 200 million electron volt mass is 120 gram, molecular mass or atomic mass is 240 grams, and Avogadro's number is given as 6 into 10 to the power 23. Is it? Then it's a matter of simplification. Okay, 1 0 gets cancelled, 6 4s are, and 4 3s are. So finally you have 2 into 3, that is 6. 2 zeros and 10 power 23 will be 10 power 25. So the required number is 6. You can say 6 into 10 power 25. So this is the answer. So I hope you are liking my videos. Please subscribe to my channel and hit the like button. Thank you so much.